it's my distinct pleasure, actually, to introduce the next set of presentations. There was a little competition during the summer school, which was a week-long event, and there were 6 teams that worked on very complex convergent science problems throughout the week, and there were 2 winners chosen based on the work, the presentation, etc. One was the Judges Award, and the other was the People's Choice Award. And it's my pleasure to actually introduce those 2 winning teams and the presenter. The first one is going to be on investigating hydrologic responses and shrinkage patterns of the Great Salt Lake. And there's a long list of contributors who worked on the project, and take it away.
Thank you. Yeah, and so thank you everybody, and to iGuide for this wonderful opportunity, and for the opportunity to participate in the summer school in Boulder this August. I'd also like to specifically thank our team lead, Irene from CUASHI, for organizing us and guiding us and instructing us through this whole process. As you can see, we're investigating hydrological responses and shrinkage patterns of the Great Salt Lake. And this project and research question was really motivated and guided by this overarching question of whether or not we can use the National Water Model to predict water supply in the Great Salt Lake. Now, the National Water Model is a large-scale hydrological model produced by NOAA, and it's calibrated at the national level with a particular focus on predicting flood events. This model uses a kind of simplistic module for groundwater prediction, as well as simple terms for precipitation and snowmelt, and really no terms for human use. Humans, the human component, is a very important consideration for iGuide, as is leveraging these large publicly available data sets in an integrated platform to answer these complex, pressing questions about coupled human-environment systems. So, for a little bit of geographic context, the Great Salt Lake is located in northern Utah. This is the largest salt lake in the Western Hemisphere and 8th largest in the world, making it a very important habitat for migratory birds. It also has a tremendous economic benefit to the region, more than $1 billion annually. However, over the last few decades, we've seen very alarming, rapid desiccation and decline of the lake. So along with these economic and ecological impacts, we're also concerned with the adverse human health effects of new stretches of shoreline that are exposed that may be bearing toxic levels of heavy metals and other chemicals. So this hydrological diagram shows, like most of the American West, the Great Salt Lake is fed primarily by snowmelt from the mountains. What makes the Great Salt Lake unique, though, is that there is no outlet, meaning that the main source of water loss in the balance is through evaporation, which you can see here. And also about 13% of water loss is to mineral production, so these salt evaporation ponds that you can see. As water flows down the river systems, large proportions of it are diverted for agriculture and cities. So with that context, I'm going to pass it over to Kat to go into the nitty-gritty.
Thanks, Daniel. I feel a little bit like a newscaster with that transition. Okay, so unfortunately we only had about 15 hours to all work as a group together, so we couldn't explore this national water model question in a particularly comprehensive or robust way, but as the climbers mentioned, this is kind of a broader iGuide question about how to incorporate new modules and other things for the national water model. But we did this exploratory analysis, and we are going to present 4 analyses to you. So, does this work? Oh, nope. Okay, I was going to try to point to things. But anyway, so the first analysis is comparing input data sets for the National Water Model precipitation to a field standard. PRISM is a field standard precipitation data set, and AORC, the analysis of record for calibration, is the forcing data set used in the National Water Model. So we want to see how these things compare. We do this in 2 ways. At the beginning of the week, we only had PRISM 30-year monthly normals, so a monthly average across 30 years for all of the months for precipitation values. But by the end of the week, we also could we downloaded some PRISM daily data sets as well that we were able to compare to the AORC 5-year average. So we do this a couple ways. We also compare USGS observed stream flow runoff values from gauges to the National Water Model outputs. So we're comparing inputs, we're comparing outputs. We also have an analysis where we put all of this together so you can see it in one place. And we do a fun visualization using Google Earth Engine and Landsat 5 and 8 data. I'll show that to you first because it's the most fun. These GIFs depict Great Salt Lake shrinkage from 1984 to 2022. We've got them depicted in 2 colors for colorblind friendliness, but also because the screen at the iGuide Summer School was yellow and we weren't sure how things were going to look. The main takeaway here is that there was a 43% decline in lake surface area between 1984 and 2023. There are some limitations to this. Namely, the way we calculated this is the maximum number of water pixels available in the best image from the year in the Google Earth Engine Landsat datasets. We don't quite know how Google Earth Engine picked the best image. It's a little bit black box. So that's a limitation. Ideally, we would be able to explain that to you. We'd also be able to say this is the same day every year or the same month every year, but we don't. It's just the best image from the year. But I think that's fine for a visualization approximation. So we just want to acknowledge those limitations, and those are all documented in our Jupyter notebook as well. The next analysis I'll take you through is comparing the PRISM 30-year monthly normals to the AORC 5-year average monthly normals. So you see the PRISM 30-year monthly normals in orange here, and then you'll see the AORC data in blue. So the main takeaway here is that the short-term averages are much more variable than the long-term average. The long-term average looks about like the hydrograph you'd expect for an Intermountain West river system. We can't say necessarily that this means AORC is more or less credible than PRISM based on this because we're comparing a long-term average to a short-term average, but we suspected that that would also show some differences if we could compare 5-year averages to 5-year averages, and that does end up being true later in the presentation. The next analysis is comparing the National Water Model runoff outputs to the USGS streamflow observations at the same gauges. The National Water Model has gauges that, grid points that match those gauges almost exactly. So you're going to see the USGS observations in black here, and then the National Water Model modeled runoff in red. 2 main things here. 1, the National Water Model overestimates runoff. This makes sense because the National Water Model doesn't incorporate human uses, and the actual water in the river obviously does. There's also a seasonal shift. We expect that this is because the National Water Model isn't currently the most robust at modeling snowmelt, and as Dr. Maxwell mentioned earlier, most surface water in the Intermountain West starts as snow. So we kind of hypothesize that the National Water Model will need to be a little bit better at modeling snowmelt and then also incorporate modules for human use to be applicable for water supply prediction, especially in the Intermountain West. Now I'll show you these 2 streamflow and 2 precipitation data sets all together. This is using 5-year PRISM averages and 5-year AORC averages. So now the precipitation data sets are more directly comparable. So the first thing you'll notice here is that the field standard PRISM data sets for precipitation show a much higher precipitation than the data sets that are used as inputs into the National Water Model. And that can kind of be an issue because you can see the National Water Model outputs in this sort of darker orange color match the precipitation data set that's used as an input pretty closely. So if there are issues with those input precipitation data sets, there's probably going to be issues with the output since they're so closely matched. And then again, in the lighter orange, as we saw in the previous slide, the USGS observations are much lower because of the factors we talked about. And this project lives on. It was an iGuide requirement and also sort of a personal desire of all of the team members to make this as independently executable as possible. We want this to, we didn't have time to create a container or anything, but we used HydroShare to store the data that we processed that would take too long to run in the context of a Jupyter notebook. And we use the HydroShare API to access those via Python continuously throughout the notebook. So ideally, any of you could go run this. There are still some access issues with this that are sort of data science specific. You have to have access to the iGuide platform, which not all miscellaneous civilians do. You also have to speak the coding languages we use, namely JavaScript for Google Earth Engine and Python for the rest of the Jupyter notebook. There's also some Bash script in there. And you have to speak English because we don't have translations available. There are also some ethical issues that are geospatially specific. We come up against the modifiable aerial unit problem because these river basins are different sizes. That's why we kind of broke apart these analyses in triptych. If you wanted to compare volumes between the river basins, you would start to run into the modifiable aerial unit problem. We also use some Americanized metadata standards for the way we store things. And then there's a point about precipitation data sets, these kind of like flood prediction, water supply prediction data sets, and that's that researchers often have more real-time access to them, and so sometimes have a slight advantage in terms of their physical safety. So we just wanted to acknowledge all of those ethical limitations, and then also our attempts to make this as reproducible as possible. And with that, we've got some references. We want to acknowledge everybody, but especially iGuide for inviting us to the summer school and then inviting us here. It's been a lovely experience. Thank you.